Okay, everybody, so I hope you had a chance to watch the first video that was just a simple introduction to computer design using the Solidworks platform. This video is going to be much more specific, showing you exactly how to CAD your nose cone that you will eventually get 3D printed. So yeah, let's get started. I apologize for the echoey nature of the video. I haven't done much recording in the past, and I am in a room that echoes, so I apologize for that. So I pulled up the Wikipedia page for Nosecone design. This is a great page. It kind of goes over each of the different profiles, and at the bottom it actually gives us a little comparison at certain speeds at the Mach number. Mach number is defined as the ratio of the speed you're talking about over the speed of sound. So Mach number of 1 is the speed of sound. And here it's kind of ranking the different nose cones and which is best, which is the most aerodynamic. So I thought that was pretty cool. Feel free to check that out. And it's going to explain everything from a simple conical nose cone and the equation for that, which is simply 2 lines, to some more complicated ones like the Van Karman, which is actually one of the hack series, a type of hack series. So that is actually what we used, the Van Karman, on our rocket last year and also on our rocket this year, and it's a pretty common shape. It's considered the ideal nose cone shape by a lot of people for series. So let's talk about also why certain nose cones are more beneficial than others. So Anil in the seminar last week talked a lot about drag, about pressure drag, about different types of pressure drag, like wave drag, and then friction drag, which is skin drag. Friction drag is a type of skin drag. So I found this article. If you Google nose cone drag and go to this Apogee newsletter article. So Apogee is a site that we buy a lot of our components from, but they have a lot of really cool stuff that you can check out, a lot of really basic articles. So if you scroll down, these people actually sent in an article where they did some testing using wind tunnel to experimentally determine the drag force on nose cones. And as you can see, something that has a cross-sectional area that's completely normal to the drag force, this had the most drag force. So this was not very aerodynamic. It's something that allows for the fluid, the air to kind of flow over it, was more aerodynamic and experienced less drag force. Pretty cool article. I recommend you check it out if you can. So one of the things that's going to be important for our nose cone design is deciding your fineness ratio. So in an open rocket, hopefully you've played around with the different nose cone types, the different nose cone profiles, and experiment and see, okay, that gives you a good apogee, that one doesn't. You played around with that. So your fineness ratio, and actually it talks about that on this page. So in rocketry and aerospace engineering, it describes the overall shape of a streamlined body. So it really just describes your profile, describes your shape, and it's defined as the ratio of your length to diameter. So L over 2R or L over D, the same thing, essentially. So that is going to be very helpful for actually plugging into one of the equations we choose. So what I chose parabolic. Parabolic is just one of the shapes you can go with. Because we're not going at a certain super high Mach speed or anything like we shouldn't be getting transonic for the most part. You don't need anything ridiculously pointy. You don't need a high fineness ratio. So in other words, you don't need a huge length of your nose cone. It doesn't need to be like the Von Karman or like an airplane's nose cone, or like a fighter jet, because you're not going to be going fast enough. So it can be something a little bit more blunt, and elliptical is good, but an elliptical is very simple, but as is parabolic. So parabolic, I chose K prime to be 1, so that just means I was going with a full parabola. So plug in 1 there for K prime, and you're good to go. So now I need to plug in L and R. So your radius is going to be defined simply by your body tube. So for the radius, that is going to be, keep in mind that that's the radius of the portion that actually is going to protrude from the body tube. So it's not going to be the inner radius of your body tube. It's actually going to be the outer radius of the body tube so that they can go ahead and align. So I did the calculations on my own, but you can do them as well. And I hope you put a lot of thought into them and make sure that everything is correct. But I did it in millimeters and said that my radius was going to be 21.5 millimeters. And I decided that I wanted a fineness ratio of 2.5 or about that. So I'm gonna make my length 107.5 millimeters. So if I plug those in to my equation, I'll get something that simplifies down nicely. We can go over to SolidWorks and get started on actually making that nose cone. So if I go to my sketch plane, I'm going to just work with this top sketch plane, enter my sketch, and I'm going to get started. So the first thing I'm going to do is I'm going to use what's called an equation-driven line. So that's under spline. I'm going to go to equation-driven curve. And it's basically a nice little graphing calculator that we can use. So I'm going to go ahead and plug in the simplified equation that I got when I plugged in my L and R values using a fineness ratio of about 2.5. And I got, let's see, I got negative 0.00186 times x squared, and then plus 0.4 times x. All right, beautiful. Now it's going to ask us for kind of our boundaries. So I'm going to start off at 0, of course, but how long do I want? So this is simply going to be your L value. So for me, it's going to be 107.5. This is a good time to make sure. You can do it in the bottom corner, or you can actually change it in your options and settings to make it there. But you can change what units you're using. So you maybe want to work in inch, pound, seconds. It just depends what you do your calculations in. This equation, I believe, won't be different. It'll be the same because it's proportional. But obviously, you're not going to want 107.5 inches. You're going to want something closer to 4 or 5 inches. So let's go ahead and click check. So beautiful, it's graphed this beautiful line for me. And what I'm going to do is essentially I'm going to close off this profile, this outer profile, so that I can get a half section view or more or less a half section view of my nose cone. So I'm going to go ahead and I'm going to just insert a couple of lines. I'm going to make sure they're nice and in the right spot, good relations. I'm going to go ahead and drag it over. Okay, so if I go ahead and click on this line right here, you can see, let's see what it is exactly. So let's check it out. So 21.5, so that's what I was looking for. The other thing you can do is actually use what's called smart dimension. And I'm going to use smart dimension to go ahead and, it doesn't just tell you the dimension, it's going to kind of lock that in place for you. So I can't mess it up accidentally. So you hit smart dimension, hit enter, you're going to be good to go with that. All right. So now, if I used a simple extrude feature like we did last time, so I'm going to go ahead and exit my sketch and use extrude boss base, I'm going to get some funky shape that looks like this, and that's not what I want. That's not a Nosecone. So I'm going to have to use a different feature this time. So I'm going to use what's called the revolved boss base. And revolved boss base is going to revolve it, it's going to extrude it, but also but in a revolving manner, and it's going to do it about an axis that you choose, or about a line that you choose. So if I want, sometimes you're going to have to insert reference geometry, like I talked about a little bit in the last video, and insert an axis, but here we actually already have the axis we want to rotate it on. Let's get on to this plane again, and I'm going to use the revolve boss base. And now it's important to make sure you're working in a sketch, so I can do that. All right, so let's revolve this around. And it's asking me what axis of revolution, so I'm actually just going to use this line right here because I want it to look like that. Okay. So when you're using revolve boss base, you can use a thin feature, but I'm going to do this a little bit differently. But feel free to try that out. So I'm going to make sure I revolve it 360 degrees. Blind is okay for our purposes. Okay, check. So I've created this solid. Right now, this is a solid nose cone, and it has no shoulder. So this is just going to sit right on top of the body too. So there's a couple of things that I still need to do. Okay. So what I'm going to go ahead and do is I am going to use a shell feature. So the shell feature, like thin feature, it's going to allow me to actually, if I click on this surface right here, it's going to shell this all out to make it a consistent thickness. And that's going to be important because I want this to be hollow. I don't want this to be solid. So I'm going to go ahead and choose how thick I want it to shell it out. 2.5 millimeters is pretty good. It's a little bit less than 1/8 of an inch. It's about 0.1 inches, and that's something I would recommend using. I think that's a good number. You're not going to waste filament, but it's going to be plenty strong for you. So I'm going to go ahead and click that. Now, let's check out what exactly I have done. So if I go up and I use section view, feel free to type that in if you can't find it. It's going to show me the section view. It's going to cut it in half and show me what I've done. So you can see here that it's a consistent thickness, and this is perfect. This is what I want. Okay, so let's get out of the section view, and let's work on our next feature. So the next feature I want is I'm going to actually need a shoulder. I'm going to need a part that's a little bit smaller than this that goes ahead and actually slides in my body too. So what I'm going to do is I'm going to work on this face right here. So this plane right there, okay? And you can make sketches on any plane, of course. So let me just turn that around for you. Yeah. And I'm going to create a new sketch. Okay. Now let's get over to the plane. And what I'm going to do is I'm going to insert a circle that I can then extrude add dimension 2. And this time I'm going to actually make it right there, okay? Because this circle, I actually want to make a shoulder that can fit inside my bodysuit. So I'm going to want it to be the same. I'm going to want the radius of this circle to be the same as the inner radius of my bodysuit, which is, I believe it's 19 millimeters. So, and that's perfect. This is, I believe it said it's 19.005, and that's perfect because we're going to sand it down a little and it'll be nice and snug. So I'm going to hit check on that, and I'm going to now extrude this out. Okay, so if I hit extrude, it shows me what it wants to do. That's perfect. But I don't want this to be solid either, so I'm going to use thin feature on this time. I use thin feature. I'm going to use the same thickness that I used earlier, so that's 2.5 millimeters. And I'm going to make sure that it comes out an appropriate amount. That's pretty short. That's going to have a hard time staying in your rocket. So I would use something closer to 1.5 inches. And we'll go with about 35 millimeters for now. That looks a little long. We'll do 30. And you know what? We'll do 25. Yes, beautiful. Okay, I'm going to hit check. And as you can see, what it's done is it's added the shoulder. But it looks like something happened, right? Because that's not smaller, is it? That's a problem. So I'm going to go back and I'm going to edit it. Okay, so what it looks like I've done is I've actually made the thin feature go outwards instead of inwards. And that's an easy mistake to make that we want to fix and get it to go inside. So I'm going to go back, I'm going to edit the feature that I did, and I'm going to go ahead and I'm just going to go ahead and reverse the direction of that. So see how it was outer before? It's going to go inside, and that's perfect. That's what I want to see. Okay. So now that looks more like a nose cone. Okay. So everything is in order. Everything is great, except for the fact that if we were to 3D print this, it probably wouldn't work. And why is that? Let's go back to our section view. So if we look at our section view, what have I done? Because the body tube thickness is about the same, is basically the same thickness as our actual nose cone, I've created this part that only sits on top of each other at a line. So this is not going to print very well, okay? So what I want to do is I want to make sure that I have these attached. I want to extrude what I've already made, this kind of circle. I want to actually go ahead and extrude it up to make sure that I have a little bit extra. So I have this kind of shoulder, this shelf, so to make these two pieces attached, okay? Let's get out of our section view. And I'm going to go ahead, and what I'm going to do is I'm just going to make another sketch. There's a couple ways you can do this. So what I'm going to do, just to show you that you can work on any face, I'm going to work on this face right here, and I'm going to go ahead and I'm going to make another sketch. Get to my plane. And what I'm going to do this time is I'm actually going to go ahead and work with the inner radius of my circle. Okay. Now that I have the inner radius, essentially what I'm going to do is I'm just going to extrude out another circle so that I have a little bit extra, a little bit of shelf. And that'll become clear once I actually go ahead and do that. So I've got that circle, beautiful. I'm going to use extrude boss base. And I don't need it to go 10 millimeters, so we'll do about 4 millimeters. Okay, now this time I'm going to use thin feature yet again. 2.5 millimeters, that's perfect. Okay, so let's see what it's doing for me at the moment. Let's make sure. So right now it's actually going the wrong direction. All it's doing now is it's just repeating what's already been done. I want this one to go up the other way, so I'm going to reverse the direction of that. Sorry, I don't want that. I'm going to actually reverse the direction in which it extrudes, okay? Fantastic. So I click that. So let's see what exactly I've done, and let's see if it's been done correctly. So let's look at the section view. There we go. So if we look at that, essentially all I did is I actually just extruded that out. We could have done that with the original extrude, but this just shows you it's not too hard to just make another sketch and go in and do that. And now when this prints, now these guys are actually attached. Now this is going to print out nicely for us, okay? And now we've got a nose cone. Perfect. So we are done. We're done with the nose cone, except there's one more thing that we need to do so that when we print these, not only do they look extra cool, but they're also distinguished.